Hello viewers, in today's class we are going to solve one important differential equation which belongs to the class of differential equations called linear differential equation, right? So let us solve this problem. Here we have to solve this linear differential equation. Dy over dx plus y over x is equal to cos x plus sin x over x, right? So why we are calling this equation as a linear differential equation? Because this equation is of the form dy over dx plus py is equal to q, right? So this equation is of this form. This is the standard form of a linear differential equation, and here the quantities p and q are functions of x, right? So if we write this equation as dy over dx plus 1 over x times y is equal to cos x plus sin x over x, and if we compare this equation with this one, then we see that the value of p is 1 over x and the value of q is cos x plus sin x over x, right? So p and q are functions of x, right? So the complete solution of linear differential equation is given by y times the integrating factor equal to the integral of q times integrating factor dx plus c, right? So the solution of this type of linear differential equation is given by this expression, and here we have to first find out the integrating factor, right? So the integrating factor is given by e raised to integral of this quantity p with respect to x, right? So e raised to integral of p dx we have to calculate, and here p is 1 over x dx, right? Okay, now the integral of 1 over x is obviously log of x, so we have e raised to log x, right? And e raised to log x, here the base is e, and we know that e raised to log x is simply equal to x, right? Because e raised to log of some quantity, say a, is equal to a, right? Okay, so we have calculated the integrating factor. Now we can substitute this value of integrating factor in equation 1 in order to find out the solution. So now the solution is given by y times integrating factor, which is x, and here we have integral of q times integrating factor. Q is cos x plus sin x over x times x, because integrating factor is x, and here we have dx plus the constant of integration, right? So now this is xy is equal to integral of multiplying these two terms with x, we get x cos x plus sin x, and here we have dx plus c, right? Okay, now we can write xy is equal to integral of x cos x dx plus integral of sin x dx plus c, right? Okay, now we can further write it as xy is equal to integral of x cos x dx, and the integral of sin x is minus cosine x plus c, right? Okay, now our aim is to evaluate this integral, and here we see that this integral is a product of two functions, x and cos x, right? So cos x is a trigonometric function and x is a polynomial function or an algebraic function. So in order to calculate this integral, we have to make use of the method of parts. So we'll apply integration by parts method to solve this integral. So now viewers, we know that the formula for integration by parts, if we have the product of two functions of x as u and v, and if we take u as the first function, then we have u integral of v, and then we have minus integral of the derivative of u, and then we have integral of v, and then we integrate this whole quantity with respect to x, right? So here we have the integral of x cos x dx. So here we'll take x as the first function and cos x as the second function, right? So we have here x, then integral of cos x, then we have integral of the derivative of x, and then we have integral of cos x dx, and the whole quantity is then integrated with respect to x, right? So now simplifying it, so the integral of cos x is sin x, so we have x sin x minus, and here we have this integral, and inside this integral the derivative of x with respect to x is 1, integral of cos x is sin x, and here we have dx, right? So now we can further simplify it by taking x sin x minus, and the integral of sin x is minus cos x, so here we have minus cos x, and we can further write it as x sin x plus cos x, right? So the integral of x cos x is x sin x plus cos x. Now substituting this value of this integral here, we have xy is equal to x sin x plus cos x, and then we have minus cos x plus c, right? Now cos x and cos x get cancelled, so we are left with xy is equal to x sin x plus c, and dividing both sides by x, we have y is equal to sin x plus c over x, right? So this is the solution or the general solution of this differential equation, right?